So thank you everyone for attending. Today's webinar is going to be focused on Genetec Intelligent Mobility, kind of with an eye towards how it supports the philosophy of open architectures and how that's an important view and kind of philosophy within the traffic industry. So the title I put here was Driving Interoperability and Breaking Monopolies. And so that kind of drives at the challenge of proprietary systems. And I'm sure if you're in the traffic industry, you've come across this a million times where you buy a product and it only talks to itself. It can't be integrated into third-party systems, and you're stuck with that one vendor for the entire life of the product. Otherwise, you're going to have to replace it all. So that's kind of we wrote a blog that accompanied this webinar that's on LinkedIn and on our website, where I go into a little bit more detail on kind of the challenges of proprietary software and why open architecture is so important. But the focus today is on Genetec and how its embrace of open architecture is facilitating this continued move in the industry towards interoperability. So as a brief overview of what we're talking today, we're going to do a quick intro of kind of what open architectures look like, as well as, who is Genetec and who are the speakers today, as well as what is Genetec's background as a product. A lot of you guys would know it for video management software and some other traditional functions. And then we're going to look at what new functionality and intelligent mobility that they're releasing now. And they've been working and really focused in this area over the past couple of years. And then finally, we're going to jump into some actual real world use cases. We'll show you a system that Stinson's deployed on the Finch LRT as a smart work zone, which kind of demonstrates the ability to integrate multiple products into a single platform and kind of the ease of use for operators and end users it provides. And then Christian from Genetec, he's also going to show us some systems that they've deployed at border crossings, and then take a quick look at kind of what the future of open architecture will look like. And it's not, right now we're talking more about unified operations, the ability to talk between devices, but no one software can do everything. So in the future, it's going to be a combination, kind of distributed services, and Christian will get into that a little bit more later. It's a little bit IT architecture heavy, so we're going to keep it very layman. But it's cool to see kind of where the industry is likely moving. And then, of course, we'll finish off the whole session with a question and answer period. So please, as we go, there's a question tab in the sidebar for the GoToMeeting. If you can please post your questions in there as we go. That way we have a nice list by the time we get to the question period. And yeah, we'll take as long as we can to answer your question, typically around 10 or 15 minutes, but we often run out of time, in which case we will follow up answers to all the questions in our follow-up email after the webinar. So thanks again for attending, and I'll jump right into it here. So just again, like I talked about, interoperability and open architecture has been a concept in the traffic industry for a long time. And it kind of all started in the 90s with NTCIP. And so NTCIP is a protocol that was created by the three key members in the traffic industry. So industry players recognized that there was this challenge of data siloing and proprietary software. And so ITE, AASHTO, and NEMA all came together to jointly develop the NTCIP protocol. And what this is a protocol that standardizes communication between devices. So whether it's a variable message sign or a traffic controller or a weather station, they're all speaking the same language, regardless which vendor you choose, such that if you want to upgrade your software or you want to change the sensor at the endpoint, you have the flexibility to intermingle these devices without having to replace everything. And so that was introduced, I believe, in 1996. And that's been very cool to see. And the challenge with NTCIP though is that it's only a limited number of devices, and it's difficult to get consensus to add more and more technology to that. And so the kind of the evolution of NTCIP as a concept has been moving towards open architectures. And that's where Genetec, and especially Stinson ITS as well, really focus in on interoperability, such that almost every product we sell has an API or has an open protocol such that it can be integrated into other systems. So that's where Genetec comes in, is kind of unified operations, getting everything into one system. And the final goal of that is just to increase competition. So purchasing agencies have been striving for competitive bids for a very long time. And when you have this lack of interoperability, it makes it very hard to be competitive. And so by having open architectures, you can section off your traffic cabinet or your ITS system into its compartmental pieces and put out bids for those specific ones without having to worry about compatibility. All you have to say is that it's NTCP compatible or that it has an open architecture, and then you can assure that it will be integratable. So that's the kind of the concept of the blog we wrote. The reason we're talking about Genetec is because it is a very open architecture type system, and it's helping drive the industry in that direction. So with us today is Christian Chenard-Lemire, and he's the team lead on the Intelligent Mobility division of Genetec. So he runs that department, and I myself am Michael McGuire, and I'm the manager of the ITS division at Stinson. So I'll pass it over to Christian to kind of talk a little bit about who is Genetec, what have they traditionally been known for, and walk you through some of that.
Of course, I was muted, so it had to happen. Thanks, Michael. So Genetec is a company that's well known for our video management platform, but we're a Montreal-based company. We've been growing very rapidly, actually 30% year over year over the past decade almost. And we're very well recognized as a world leader for video management solution. We're the first to introduce IP-based video management solutions 22 years ago. But we also are well known for access control, license plate recognition, so mostly security-related concepts that we have, but that we're now putting to use inside the intelligent mobility market. We have a global presence, so around 150 countries. We have offices a little bit spread across the world, but most of our business comes from the cities and infrastructure market. So hence our interest in the intelligent mobility market. So we just wanted to show a little bit the different places, the different customers that are trusting Genetec for mainly, again, video management, but in some cases there is some ITS customers in there as well. So here are a few cities like Montreal, Toronto, Ottawa, a bunch of municipalities in the Toronto area that are using Genetec for video management purposes. We also do a lot of border crossings, all the ones around Niagara, the Blue Water Bridge as well, Pembina, Emerson, and Pacific Highway crossing. And there they're using, their ITS installations where they're using border wait time solution, as well as dynamic message line control. And in terms of the ministries, we also have the MTO and MTQ that are using province-wide our system mainly for video management, but also having some ITS functionalities on there. And then some of the highways, like private highways, also they're using like the 407 or the 825 by Transurban in Montreal. So this just to give a quick glimpse of the customers that are currently using Genetec in Canada.
Yeah, perfect. And then kind of a who's who of the traffic industry, certainly in Ontario, we come across it all the time. So it was a very logical step to move into ITS and mobility more generally because they were so exposed in that market. So this is kind of the view that you probably would see if you went to City of Toronto or the TTC or any of these major organizations like the MTO. This is a big video wall. Typically, it's Genetec that's running that video wall, providing you a glimpse at all the cameras in your city. And so the big focus was talking to as many cameras as possible, getting that video all into one place so that it can be managed, recorded, and controlled. But they've also, like Christian said, they've done access control, license plate recognition, as well as operator workflows. So mission control is listed there. That's all about operator workflow control. And so allowing the automation of workflows for operators. So if an incident happens, it can prompt you to walk through a predefined process so that you ensure that you do everything you're supposed to, as well as that is recorded and audited or auditable later so that you can make sure that things were done properly. So again, the big advantages that Genetec's brought to the table is open architecture, distributed architecture, so you can have a combination of multiple systems all talking to each other. You can have cloud plus on-site or on-premises deployments. And a lot of these key functionalities, their rules engines, their automated workflows, it all lends itself very well to mobility. And you're going to have different inputs from different sensors, and you're going to be controlling different devices like DMS and beacons and things like that now. But the core concept of the decision-making framework that they developed is very transferable. And so this is kind of what you know Genetec for, and a lot of people haven't seen. They've been doing this for about 4 years. We've been working with them for about 3 years now, but a lot of people don't know what they've been working on. So I'm sure you'll be kind of shocked as you go through this, but let's get into it. So the 4 roles that we're going to be talking about today, and these are not exactly the modules, we'll jump into that in a later slide, but the 4 key areas that we kind of see opportunity for Genetec Mobility to really take a place in the market is 1, fleet monitoring, then incident detection and response, and that can happen in a few different ways, flow management, both on arterial roads as well as on the freeway, and then remote enclosure security. And I put this one in there because the traffic industry is notorious for having very poor traffic cabinet control for their security access. We'll show you a screenshot later, but I'm sure you're familiar that this number 2 key opens almost any traffic cabinet in North America, and it still blows my mind that that has not changed in the 10 years that I've been in the industry. But anyways, we'll talk a little bit about that more later. But I'll pass it back to Christian to talk about, unified operations and what that looks like and what it achieves.
Yeah, no, it's a good point. What we strive to do and what we've started doing and mostly achieved in the last 4 years is really to unify the different types of sensors and systems that are used in a traffic management operation scenario under a single pane of glass. And the idea here is to improve the situational awareness of the operators, but also improve the way that things can be automated using all of the data. So this helps operators understand what's happening in the roadway, understand the traffic patterns, but also either through the operator's manual input or through automatic detection, we can rapidly identify incidents using multiple types of analytics, both on the video side, like video analytics, where we have several partners that we work with, or on the data analytics side, where we can analyze the traffic data to identify specific scenarios. And then we can use that to automate some routine tasks that an operator would need to do, like emailing someone or even moving a camera or changing what is being displayed on the sign, and help the operators go through a planned response with a step-by-step procedure. The other big thing is that Genetec can be tailored for different types of agencies. So it's not just traffic. We're very present in public safety agencies, transit, and other even public works. So what we can also do is help that collaboration between the city through what we call our federation model, where we can bring together the different systems that each department owns into, well, they can collaborate and share information across systems securely through our federation. And this helps them have a common picture of what's happening, and then helps them collaborate as well.
Perfect. So this is a quick glimpse at the kind of general portfolio of Genetec. And so at its core is Genetec Security Center, which is what you guys would be most familiar with, as well as Genetec Mission Control, which is that workflow management tool I was mentioning, and they pair very well together. So that's kind of the core systems. And what we're focusing on today is these 6 modules here that I've circled in red. These are the intelligent mobility modules, and these are kind of used in various combinations to enable functionality. And so in the upcoming slides, we'll walk through a couple of different use cases on how they're utilized for various roles within a city or municipality. So one is fleet monitoring. This allows the integration of AVL systems. We can interface directly with a GPS modem on a vehicle, track its location, do geofencing to set up certain rules for exiting or entering those geofences. But we can also just integrate a third-party AVL system as well, whether it be Geotab or someone else, we can pull data from that. And so we can integrate video feeds from the systems. We can integrate people counting sensors, or if there's a crash attenuator on it or an arrow board, we can see what is the status of this device and record that for perpetuity, even for accidents analysis and legal disputes. We can pull up a replay function to have that as kind of an archived history and recording of what that vehicle was doing at that time, both the position as well as all the data related to the system. So we also have digital signs with the DMS module. This is a key one. So Genetec's a big supporter of NTCIP. So whether it's their weather stations or message signs or other sensors, dynamic lane control, they support the NTCIP protocol. So this comes down to small PBMS message boards up to the full message boards across all lanes on a highway, whether it be amber, full color, graphics, you name it. And they have a very robust rules engine and priority system to really be able to customize the messaging quite a bit. They also have dynamic lane control. This isn't so applicable in Ontario, but certainly in Quebec and elsewhere where you have a lot of bridges. This is important. So this is basically the control of those dynamic lane change signs, so that changing it from one direction to the other, and kind of all the logic that goes into that to make sure it's a safe transition one way or the other. They also have the weather monitoring module. This allows them to integrate all the weather sensors that an agency has, as well as third-party weather data services, and pull that in so there's just more context when you're analyzing a situation. And these final two, the travel times and the transportation sensors, this is really when traffic sensors get pulled into the platform. So travel time data can mean pulling data from a license plate reader or a Bluetooth or Wi-Fi sniffer, or even RFID tags, pulling the raw data into the platform and generating travel time data from those matches directly. And this allows interoperability. So Genetec has integrated the Stinson Bluetooth Wi-Fi sensor. They've integrated TPNA and a few other ones as well, such that you're not locked into a single vendor. Exactly what we're talking about today is interoperability. So you can have the flexibility to choose the most competitive or desirable sensor and know that it'll all work with your existing system. But that travel time system also includes third-party systems like Azure Maps and INREX and larger big data providers of travel time that can also be ingested. And for transportation sensors, this is a look at kind of your traditional radar count stations, video analytics from cameras, if you're counting bikes and pedestrians, you name it, your traditional loop count stations, that can all get pulled into the platform as well to provide kind of dashboarding and reporting within the platform. So now we're going to jump over to kind of 4 different kind of use cases that we see. And again, it uses a combination of these various modules to perform some interesting kind of functionality. And I'll hand it back to you, Christian.
Sure. So the first step is monitoring, right? So we wanted to bring the data in from different types of sensors into the platform. So a little bit like what Michael just described. On top of the video monitoring, which we're well known for, now we can add traffic data monitoring, whether that comes from video analytics or from radar sensors, ground loops, or other types of traffic sensor. And that could be both vehicle, but also bike or pedestrian. It really depends on what the sensor can output. And then also bring in weather data. We can use that data also to do parking monitoring, parking occupancy monitoring, sorry. And then we also have the dynamic message sign that we can see what's being displayed on the sign, but also actually in this case control them. And then use all of that data to do incident detection and then help with the decision support, which we're going to go to next on the incident response. So that's the first step, right? It's the situational awareness. But then we want to actionize that information. And so what we're doing is the first step is for operation is to really identify when there's a problem and then what you need to do to resolve that problem, right? So we're starting with detection of the incidents. So that could be from video analytics that can detect a broad number of different situations like a stopped vehicle, wrong way, an object on the road, things of that nature. And then we can combine that with data analytics, such as looking at the speed or the volume and looking when there's a certain threshold that gets crossed, or looking for abnormalities, comparing the current, let's say, travel time from the normal travel time at this time of the day and this day of the week to see if it's, let's say, 50% over the historical average, then we can trigger something as well. So actually with all that, we can do queue warning and all that through the data analysis, but we can combine the data analysis and the video analytics together to really try to identify specific scenarios as accurately as possible. And once that's detected, then we go through the response. And this is where we have a dynamic procedure that's on screen. We can see it slightly on the right there, where an operator can go step by step through the process of resolving an incident. And that procedure is actually dynamic. So depending on what they answer or depending on the inputs that come in from the system, the procedure might change. And then there's also, at each step of the procedure, there's a automated workflow that can be triggered. Things like displaying a camera to someone, PTZing the camera, displaying a message on a sign, sending an email to someone, and a number of other actions that can be taken automatically. And then obviously with all that, we monitor the response time for each step. Everything is monitored so that we can see if a specific step is taking too long, then we can take action, or in general, just looking at our general KPIs is seeing how well are we doing in terms of response and resolve time. And another key aspect, mostly for urban situations, but also for like truck parking, is what I talked about a little bit, the parking occupancy. We can go a little bit further and actually do parking guidance. And the idea here is that we look at we take sensor data like the ins and outs of vehicles, and that could be simple sensors, could be license plates to link that to the permits or the payment system. But it could be also ground pucks like bay by bay sensors. And we can, using that data, measure the occupancy of a whole lot or section of a lot, or even some specialized spaces like the handicap or electric vehicle spaces or things of that nature. And we can display that parking availability on dynamic message signs and also help guide the vehicles to a parking spot. So meaning that we can actually change what's being displayed on the sign, not necessarily just displaying the availability, but based on the availability, we can display different things on the sign. For example, if the lot 1 is full, then just display, go right to lot 2 or something like that. So we're actually directing the flow of traffic using the digital message signs.
Beautiful. Now, Christian, I know you guys have a full suite of parking products, like all the sensors and everything to manage a parking lot yourself, but yeah. I believe this back to the open architecture, I believe you can also integrate with third-party systems. So if there's an existing parking lot that has the data on the in-out and the capacity, you can just ingest that into the system and it can drive this messaging just the same. Is that right?
Yeah, exactly. Well, I'm going to touch base on that in the architectural stuff, but everything that we do is API based. So that means that there are ways either through an HTTP API or a message queue, like a pub sub type of mechanism, to send data into the system so that it's not tied to one specific type of device or system. And the system-to-system integrations are made easier through these APIs.
Perfect. And the last one.
Yeah, that one is it's a bit of out of topic, but still really interesting to this market. The infrastructure security. So there's tons of cabinets out there, mostly secured by this top security threat, which is the number 2 key. So that key is widely used, can be bought on eBay very cheaply. But even people that are using another key, a proprietary format key, quickly the key management it falls short, right? So who has that key? How many keys are around? When somebody leaves, did we take their key back? If their contractor has it, when is he giving it back? Like all that key management aspect is difficult. So what we decided to do is a few solutions around using electronic keys or even an electronic lock to be able to monitor who has access to what cabinet and from even granular, like to at what time they have access to those cabinets. So you can manage the access if your cabinet is networked. You can actually manage that dynamically, meaning that maybe in one time you have 1,000 people that have access, and then in the next moment you only have 10. So you could dynamically adjust that based on different threat levels or things like that. And you can also do a video verification. So if you point a camera, like you could every time somebody opens the door, you could PTZ the camera to the cabinet, take a snapshot, or even just leave the camera on there for the safety of the operator, just make sure that they're okay throughout their maintenance work. And you can even unlock that at a distance. So if you're connected and the contractor gets on site, forgot their key, whatever, they can call the control center, and the control center can verify by video and then unlock the door remotely. So those are all things that are very neat. But on top of that, you get a bunch of report around who accessed the cabinet and when. And so especially for contractor management, when you have several contractors working in your cabinets, you can verify who went into what cabinet, who's the one that screwed up this or that, or even how long they were in that cabinet for. So you can really manage and make sure that that the access are really well granted.
Yeah, exactly. Like Christian said, a little bit off topic, but this one drives me nuts, and it's really cool. Genetec, I think, the only one really focusing in on this area for the traffic industry, and I find
like
that
we said, you could screw a city by with a number 2 key in a bucket of water.
Yeah, that's my famous line. Yeah. So I can't think it hasn't happened more often, but it's still an ongoing thing that drives me a little crazy.
Yeah.
So I'm just going to jump in. Let me see if I get my screen straight. So I'm going to show you a system now. This is so Stinson won the contract for the smart work zone along the Finch LRT corridor, which is going to be built over the next 5 years, I guess 4.5 years now. And so what that involved was a travel time system where PVMS boards are placed out there with travel time sensors in there. And that's gathering data on Bluetooth and Wi-Fi systems or smartphones and vehicles driving by, and calculating the travel time and then posting that on message signs. So that's kind of the core is the travel time system, but we also deployed a number of CCTV cameras at all the major intersections across the corridor. And we're streaming that back over wireless ISP connections at 1080p continuously back to our office. So we're providing this kind of as a cloud service to our customers. And so it's an interesting look into kind of interoperability and the ability to integrate multiple devices. So let me just make sure I'm So let me pull this up here. I can use that. Can you guys see the Genetec screen there?
Yeah. But we're also seeing your keyboard for some reason now.
I'm also seeing my keyboard. Oh, it switched cameras for some reason. Okay, let me go up then. Is that okay?
Yep, that's good.
All right, perfect. So this is the platform that we provided to Mosaic, who's the constructor on the Finch LRT. So to give you an idea of layout that they would typically look at, these are a glance at the dashboarding that's possible. You can see there's a bunch of devices, a bunch of different layouts, but it just shows you the customizability of the Genetec dashboard. It's not just video. You can also put map-based interfaces that have data on them, so you can see the various lines on there, the green lines on the road and the red lines, much like you'd see on Google Maps, but this is driven by our Bluetooth and Wi-Fi data that's out there. So you can at a glance see what is the travel time along the roadway, what are the messages being posted on those PVMS, and then you can also get in and control the cameras. This is a live system, so I'm not going to move anything here, but it gives you an idea of what we're capable of. And you can see this is, actually I was wrong, it's not 1080p, it's 720p, these cameras, but they're streaming constantly over this unlimited bandwidth connection back to our office. So we have an archive, I think, of about 2 years available to them, so they can go back in time as well. So this is a cool integration of video cameras, map-based interfaces, and PVMS, NTCIP control, and Bluetooth Wi-Fi ingestion. But I want to show you, we also have a MyoVision system that we've deployed at Jane and Finch there. And this is an example of a third-party integration. So that MyoVision system, if you're not familiar with it, MyoVision is a video detection system that would typically control an intersection, but it also generates a lot of data. And I'm not sure why these 360 feeds are not showing. I had this problem earlier. We'll see if they kick in. But it's sitting at the intersection with a 360 camera, and it's providing stop bar detection, and you can see that in action here. Maybe I'll just maximize that so it's a little more clear. I'm not sure why that's lagging, but anyways, what you can see here is that the stop bar detection is occurring, but in the top right here, you'll see this purple view. This is the vehicles being classified and counted, and they're turning movement counts. And so this has been a really important tool for the Finch LRT corridor. We deployed this system for Metrolinx because they were very interested in seeing the data. And what we ended up using this data for was kind of comparing what was the pre-COVID conditions like and what were the kind of conditions as we return to normal. And what we did was we were able to justify an increase in the construction work schedule based on the reduction in volume compared to normal. So because of that, during the summer months, we were able to get, or Mosaic was able to get permission from Metrolinx to do a lot more driveway closures and lane closures when they traditionally wouldn't have. and all through demonstrating that the volumes had dropped sometimes up to 80% along this roadway. And so, of course, things came back to normal, and so that's kind of stopped over the past few months. But again, we're moving into a new lockdown now, and so we might see drops in volume again. And so that data can be used to justify increases in work schedule. And so it's a nice example of data-driven decision making, and it's been a very cool project for us to deploy. And you can see here the data feeds or the video feeds have been pulled into Genetec, and now we're in the process of integrating the MyoVision API so that we can get all this turning movement count data in here as well. And because they both support open architecture, we're able to combine the two systems together. And so it's just a great example of what a unified system looks like, where I can get my fingers on everything that's deployed on that corridor, all from this single platform.
I think what's also beautiful about this is whoop, there's an echo, Michael.
No,
not sure where that's coming from. But is what we're talking about in the open architecture here is an API to API communication, and in this case, that intermediary that can translate from one API to another can come from anybody. It could come from Genetec, could come from MyoVision, or any third party in the middle that creates that integration. So using standard APIs like this has really strong benefits when it comes to system-to-system integration.
Exactly, yeah. Okay, so that's it for the system. I'm going to pass it back to you, Christian, if you want to jump in and take control. I think, Samantha, if you can transfer over presentation rights to Christian.
Wait, are we not doing the border wait time?
Oh, sorry, I forgot about that slide. All right.
Anyways, I don't think
go for it.
Yeah. I don't think whoa, you're wrong screen.
No, that always seems to happen when I do this. Let me just switch over here. Okay, go for it.
There you go. Okay. Yeah, so I didn't prepare a demo for this part. You also have your go to meeting stuff on the right there that we see. But I didn't prepare a demo for this, but I wanted to talk a little bit about the border wait time because it was actually quite a complex project that we achieved. And we first started in the Niagara region for the border wait time at the Peace Bridge. And then we expanded to the Rainbow Bridge and the Queenston-Lewiston Bridge. And now it's deployed at the Emerson Crossing and Pacific Highway. But what was interesting there is that we explored with them the different ways of being able to do border wait time, and using at first Bluetooth technology, where we would measure put different Bluetooth detectors around their plazas and try to measure the wait time using that, which works really great for let's say your standard vehicles going through. But what we quickly realized is that it became really difficult to do this for the specialized vehicles. Like the commercial vehicles, or they have like what they call a fast program over there. And we tried a bunch of things like directional antennas and things like that. But in the end, what we really realized is that license plate recognition was really going to do a better job for segregating these specific vehicles. And so what we ended up with a hybrid system of Bluetooth and LPR, and we adjusted our algorithms to be able to filter out some of the data from one to the other. So for example, if the commercial vehicles we're using LPR, if they're slowing down, we're still detecting their Bluetooth, so we don't want their detections to be part of the overall calculation for the non-commercial vehicles. And so we did a bunch of adjustments to be able to do that and really improve the overall travel time engine through these projects. And now we have a travel time engine that is highly customizable to all different types of scenarios. Like something like this could be really well applied to, for example, special lanes on a highway, like an HOV or HOT lane, or electric vehicle lane, or whatever else special lanes that we could use to. We could measure the travel time for the general lane versus those dedicated lanes very easily using those algorithms. So that was a really interesting project I just wanted to highlight a little bit.
Absolutely, yeah, no, that's great. And I know that the MTO, kind of talking about federation, I know the MTO pulls information from the system into their instance of security center. So it's good to see that you can share between agencies as well.
Yeah, and there's again an API, right? And it's actually, in this case, it's a public API because the CBSA wanted other entities, whether public or private, to be able to access that data freely and be able to do something with it, right? So there's some trucking companies that bring it into their system and whatever, but so that API is has been really useful for a bunch of different people.
Oh, very cool. Okay, great. So that's kind of a look at some real world systems that are deployed. Now, Christian's going to talk a little bit high level about kind of the future of open architectures, and that's focused around what's called microservices. And it's a little bit complex, but we're going to try to keep it simple for you, so you get an idea of what's coming soon. Sorry, I'm clicking the wrong button. Let me jump to the next slide. And I guess I'll talk about this part first, is just kind of how data moves through the system. So data is becoming more and more of a, I guess, a source of information, and the amount of data is exponentially growing. So a system has to, whether it's a single system or in this case a distributed architecture, that data has to get ingested, then it gets, kind of put into a central location of some sort, correlated and analyzed, and then that allows you to, share it with third parties. And oh, sorry guys, You also, so the data comes in, you correlate, analyze, you can then share it, much like Christian just said, with the border wait time. So that data can be normalized and then just passed right on to a third party, but it also can be passed on to a system like Security Center, which can then visualize that data for you. And as well as, I forget what the last tab is, it's actionize. So that workflow stuff, whether it be manual or automated, can then be, that data can then be actioned on. So this is where we'll jump into microservices a little bit more.
Yeah, so like Michael's saying, we wanted to talk about this just to show the people here the way that we see the future of this market going, and but it does get quite complex. So we try to bring it down to at least the basic principles. So this is really about digital transformation, and what I put here, the three buckets. So there's a lot of things that are going to show up on the screen one at a time. But the three buckets I put there: Genetec, which would be Genetec applications, and again, these could be interchanged with third-party applications. It doesn't need to be Genetec. I'm just showing where Genetec might play. And then there's a city, which is what the city network infrastructure, what they own. And then there's the third parties also, just to show that this is an ecosystem, right? So where Genetec is not, it's just a piece of the overall puzzle, and we know that, and we want to coexist with these other applications that also bring value for the city. And so this is where we want to go. So you can start a few things. So all right, so we start with the inputs. Now we're talking about it could be video cameras, it could be traffic sensors, vehicle data, traffic light data, weather information, IoT devices, all that gets put into what we're going to call here ingestion services. So these ingestion services, their sole purpose is to take the data from the inputs and then normalize that data into a feed that can be understood by the other applications. Once they do that, they publish that data into what we call the transport layer. And that could be a number of things. Typically, it's a publish and subscribe type of broker. So where the data can be published by the ingestion services, and then other services can subscribe to that data. But it could also be APIs and things of that nature. Then once that data is in here, it can be accessed by a multitude of different services, namely the data analysis services. So these services, and like I put here, it could be a Genetec service, could be a third-party service, could even be a city service, takes in the data, analyzes it, and then spits back result into the data transport layer. So that could be, for example, the travel time engine, which we have, is exactly like that. It takes in data from, for example, the MQTT broker, analyzes it. So it takes in the raw detection data, analyzes it, and then throws back travel time data into that same broker. Then the city, wants to keep some of that data, some of the historical data at least, into what we're going to be calling the persistent layer. And that could be an SQL database. It could be any number of different types of database. It could be just blob storage in Azure. It could be a number of different things. But here is what's important is that the city owns that data. So they don't have to have like a constant contract with company XYZ in order to have constant access to their data. The data is theirs by default. And yeah, the data analysis services can actually use that data also to look at historical data analysis, for example. In some cases, you might have a direct line between the ingestion service and data analysis service, and then only receive the results back into the transport layer. That really depends on what the city's goals are. Then we have the Genetec Unified Operations Platform. And so this is what we were showing with the Finch example, but this is the platform where you're going to see everything and actionize your information. So the data, how it gets there, oh yeah, and you could have also third-party applications that will consume that data. So if you want to click through to the next. So the data gets there through that city transportation data layer. So just, I'll pause here for a second, because typically what we have in the market right now is that those applications like the Genetec application will talk directly with the inputs, right? So all of that thing in between doesn't exist right now, which means that there's a silo of data that gets created within that platform that is not accessible by third-party applications unless you do some sort of integration. So what we're trying to do here with this new architecture is negate that and bring the data into a place where it can get broadcasted to all the applications that need it. Obviously, there's a need for data governance and making sure that whatever application needs to have access does, and the ones that don't need to have access do not have access to it and all that, but that gets put into that transportation layer. So if you want to click through to the next. So then I put the city operations there, right? So that could be the traffic, could be public safety, could be transit operation, whatever. They will consume the data from the Genetec system or from third-party applications, and then act on that data, right? So there will be inputs from the operators that go into those platforms, and those inputs can go all the way back down into the city transport layer, so that when somebody clicks a button in one of the application, that action gets put down into the transport layer, where that could trigger, let's say, a workflow, or that could trigger a data analysis service, but it can be used as a trigger like that. And then if we continue down, then you'd have, if you want to click through to the next, yeah. So then you would have action services that what they do is they actionize these inputs either from the workflow management service or directly from an operator input. They will actionize that data onto the active devices. So that could be a PTZ control. It could be displaying a message on a sign, or changing the timing on the lights, or acting on the PLC in the field. But any of those actions that need to be taken to the field would go through these action services. So overall, what that creates, and we talk about microservices because now instead of having these big monolithic services that do a bunch of things, you have a bunch of small services that are very targeted and specialized into what they do. And so that's generally called a microservice architecture. Now, what's interesting about that is that we can use these services. They can be deployed wherever it makes more sense, right? So an ingestion service could be deployed on the edge, for example, but it could also be deployed on a server within your network or in the cloud infrastructure. And there are services like Kubernetes and Docker that are made for that, for portability of these applications into different types of architectures, so that you don't need to be locked into a cloud-only infrastructure, for example, right? So you can move your services around as best fit for your own needs. Then also all the communications go through that central layer. So that means that the city actually owns that layer and has complete control over how things are communicated, how the data is communicated between the different systems, and more importantly, owns all the data, right? There's no question about it. So it becomes really interesting. And then the integration.
We've reached the end of the webinar here. If you want to give a quick wrap up.
Oh, okay, sounds good.
We'll jump into a few questions. We'll stay a little bit later for the questions, but we will follow up with a recording if you guys want to see those answers.
Yeah, no problem. Sorry, I didn't look at the time. But the big picture here is that we're moving the proprietary nature of the system-to-system integrations. That's the real big benefit here, and this is what we've been driving. And I'm sure some people on this on this webinar can recognize themselves here, where we're testing these waters with different cities.
Exactly, yeah. So, and Genetec has a key piece to that, but it's never going to be the full answer. And so it's going to end up being an ecosystem of interoperable software platforms that can all work together. Yep. So for questions, let's jump into that now. Sam, do you want to read out maybe the first few, and we'll just keep going until maybe for another 10 minutes? Might be able to pull them up here as well.
Yeah, I don't see any questions on the question board. Oh. Or did I not see them?
I remember I had trouble seeing them last time, but I don't see anything. All I see is a thank you.
Yeah, same here.
I can read the questions for you guys. The first question is, you mentioned incident detection. Other than video analytics, what other incident detection technologies are you able to integrate with in Genetec?
Okay, yeah, that's a good question. So on top of the video analytics, we have several partners in video analytics that we work with for different detections, but we can also use other types of technology that can send events, right, for specific situations. A good example is NAVTEC, so a NAVTEC radar or something similar, but where we can have, let's say, a radar that detects a stopped vehicle or a vehicle going in the wrong direction. It could be thermal, it could be LiDARs. There's a number of different technologies that can detect these specific types of scenarios and then send that as an input to Genetec. So video detection is great. It works really well in certain scenarios, in others less. And these other types of devices can come and fill that gap. So that's and of course on top of that, we have our own data analytics that can be utilized to detect some types of incidents.
Okay, thanks, Christian. The last question or the second question is, you briefly mentioned the traffic cabinet smart lock. Can you provide more details on this? It has been deployed. Has it been deployed somewhere?
Yeah, so we've done it in Canada. We deployed it in the US in a few cities. The most notable one was in Atlanta for the Super Bowl back in 2015, I think it was, or 2016. I forget which one. No, that seems too far away. But anyways, we deployed. So they were actually, the use case was really interesting because the FBI came in and they said that for the event they needed to weld shut all the manhole covers, which is standard procedures, but they also wanted to weld shut all the cabinets because they saw it as a cybersecurity threat, right? Somebody could get into the city's network through those cabinets, and the Georgia DOT was freaking out, that you can't weld shut our cabinets, and they said no, we have managed switches in there, they're protected and so on, and the FBI quickly showed them how they could circumvent that in about 10 seconds. So they were flabbergasted that their system was so exposed, and anybody could come in and connect into a dead port into their managed switch and just get in anyways. Well, not anybody, but somebody that with some good skills. And so it was funny because the security officer over there was like, so you're telling me that if they get into a cabinet close to the stadium, they could change the light in the stadium? And we're like, no. We're telling you that if they get into a cabinet across the city, they could change the light of the stadium. they're like, okay, what's happening? So obviously it's not exactly true. There was a bit of drama there, but it made them realize that they needed to protect that. And they deployed our system in all of their connected cabinets. And so now they have a full access control into all their connected cabinets so that they can know exactly who accesses and when. But more importantly, they have a dynamic way of changing that access. So for the FBI, for the event, they didn't want anybody that had a number 2 key to be able to access those. They wanted only maybe a select few, maybe 5 or 10 people to actually have access. So all they had to do was change the access rule to say, all right, now only these 5 cards have access to those cabinets, and the FBI were really happy with that. So that's obviously a very strong example, but in general, we have a few other cities in the US that are looking at this just as a method of securing their critical infrastructure against cybersecurity threats. So it's funny because it's an infrastructure thing, but it's for cybersecurity reasons mostly.
Exactly. No, that's pretty cool. All right, well, I think that's it for the questions. Sorry, guys, we've gone over again. It looks like 7 minutes over. So let's wrap it up here. Again, any other questions, please email it back to us, and we'd be happy to answer them for you. Our next webinar will be on January 6th, and it's going to be on intelligent warning systems from TAPCO, and focused on these 3 ones here: the overheight warning systems, intersection conflict warning systems, and fire exit warning systems. So I hope you'll join us for that one. And that's it for us. Christian, thank you so much for taking the time today.
Thank you.
And that was really great.
All right, thanks. Have a nice day.
All right, bye everyone.